Okay, how about this? If a binary relation is transitive and symmetric, then it is also reflexive. Is it true? Think about it, okay? Give it 30 seconds. Okay, think about it, but on the same page, I also want to ask the question I asked on the previous slide, which is, can you have a relation that is what? Yeah, transitive and anti-transitive at the same time. You think not? Okay. Zen, right? Ibrahim. Who is Zen? Oh, okay, sorry. Okay. Right. Two Ibrahims are sitting together. Yeah. Give me an example. So I'm asking for an example of a relation that is transitive and anti-transitive. Okay? Go ahead. Oh, sure, think about it. I don't know, you tell me. That's the question. Is it contradiction? You think so? Okay. Think of the simplest possible relation that you can have. What's that? Yeah, to my view, this is the simplest possible relation, okay? Think about this thing. Is this transitive? And is this anti-transitive? Yeah? It is transitive and it's also anti-transitive. Okay? Okay, so can you have a relation जिसके अंदर कुछ arrows हैं? It's not an empty relation. Can this thing be transitive and anti-transitive at the same time? You don't think so? You have an example of it? Okay, go ahead. Okay. Okay. Yeah, cool. As long as you have only one edge, or the edges don't concatenate, you would have transitivity and anti-transitivity. Okay? The way I'm constructing these examples is quite simple. What I'm doing is I'm making the premise of the definition false. है ना? जब मेरी premise false हो जाएगी, मुझे conclusion check करने की ज़रूरत नहीं पड़ेगी. Okay, that's what I'm doing. Premise के लिए मुझे दो edge चाहिए थे. Okay, I'm making sure कि कोई दो consecutive edge है नहीं. Okay, अगर मैंने A से B तक edge बनाया, फिर मैंने B से आगे कोई edge नहीं बनाया. Okay, और C से D बनाया तो फिर D से आगे कोई edge नहीं बनाया. Okay, अगर ये मैं एक यहाँ पे कहीं पे कोई edge डाल दूँगा, तो फिर then I'm in problem. Okay, फिर ये relation cannot be transitive and anti-transitive at the same time. Okay, you see the problem? If I have an edge from this thing to some place else, अब ये वाला edge अगर मैं डालूँगा तो ये transitivity की तरफ चला जाएगा, ये वाला edge नहीं डालूँगा तो anti-transitivity की तरफ जाएगा. तो इस edge के बारे में मेरे पास कोई choice नहीं होगी. Okay, so what I do is I make my premise false. Okay, cool. Let's come back to this problem. Can you have a binary relation simultaneously transitive and symmetric and not reflexive?
Yes.
Okay, go ahead. Okay.
X is equal to 1, y is equal to 2, z is equal to 1. इसका हम relation construct करें 1 2 2 1 and 1 1.
Okay, hold on a second. Let me I'm using board more and more. I probably should bring a tablet or something. I don't know. Okay, so you are saying, go ahead.
X.
Okay.
Y.
Okay.
Z.
Okay.
X is equal to 1.
So x, y, z are variables. Okay, so this is 1
2,
and 3.
1, 1.
This thing is 1.
So also 1.
You want z to be 1. Okay, cool. So you only have two vertices.
And x are more than 1.
Z and x are both 1. Okay, so you are saying that
From 1 to
x is equal to 1 and z is equal to 1, right? And you're saying y is equal to 2. Okay.
अगर हम x y करते हैं तो 1 2 होगा.
Okay.
फिर हम और y z करते हैं तो 2 1 होगा.
Okay.
तो फिर x भी हमारे पास 1 1 होगा.
Okay. So you have these 3 arrows. Okay.
ये ट्रांजिटिव की सिमेट्रिक की लेकिन रिफ्लेक्सिव नहीं है.
Is it though? Is it though? It's not transitive. You need this loop to make it transitive. See? Yes, fancy example crashed. Okay, cool. Let's think about it again. Can we have a relation that's transitive and symmetric but not reflexive?
अगर एक ही पॉइंट तो हो सकता है.
Sorry, what?
If you only have one variable, अगर एक ही पॉइंट
Yeah.
तीनों हो सकते हैं.
So देखो, okay, let me kind of, I think problem लोगों को समझ नहीं आ रहा. The problem,
सिमेट्रिक नहीं होगा. ट्रांजिटिव और रिफ्लेक्सिव.
okay, so the problem is that someone says that I have a relation that's reflexive and symmetric, but it's not, sorry, transitive and symmetric, but it's not reflexive. Okay? I want you guys to doubt that statement. I want you guys to think, okay, no, it's not possible, and then give an argument in that way. This is actually possible, okay? But in very specific cases. For example, if you remember this relation, you remember this is transitive and this is symmetric and it's not reflexive. Okay? ठीक है? Okay? No? Why not? The guy behind you. So look at this relation. ये वाला जो relation है ना, I'm not drawing anything, okay? So this is a relation जिसके अंदर सिर्फ एक element है and there are no arrows there, okay? अब this thing is transitive, right? Transitivity की जो condition है वो true हो रही है क्योंकि उसकी premise false है, okay? This is also symmetric. कोई edge है नहीं तो जिसकी मैं symmetry check करूँ, है ना? But it's not reflexive, है ना? अगर मैं ये वाला loop डाल दूँगा तो ये reflexive हो जाएगा, but in itself it's not reflexive. Okay, so it's a relation that's transitive and it's symmetric, but not reflexive. Okay, so it's possible to have this. Okay, but what I want to say is that there are very specific cases जहाँ पे ये हो सकता है. Okay, let's see some examples. So here is. Here's a relation that's transitive, symmetric, and reflexive, all three of them, right? Why did I draw this? I was supposed to miss some of the edges to kind of give you an example कि ये हो नहीं सकता. Except for a trivial case where an element is not related to any other element, okay? So अगर आपके पास इस तरह की situation है ना, तो उस case में तो ये होगा. Okay, you have a relation that's transitive and symmetric, but it's not reflexive. Otherwise, these two conditions mandate reflexivity. Okay? Why is that? Why is transitivity and symmetry mandating your relation to be reflexive? Let me give you an argument for that, okay? Again, अब assume करें कि ऐसा नहीं है, कोई एक element अकेला कहीं पे नहीं पड़ा हुआ, okay? So what's going to happen is that you have an element, this is connected to something, right? It cannot be alone, okay? So let's say that this is connected to this guy, okay? So let's name them, okay? Let's call this A, let's call this B, okay? If A is connected to B, Then by symmetry, I should have something. I should have BA, right? Awesome, cool. If I have AB and I have a BA, by transitivity I should have something else. I should have loop, okay? So that's the reason that symmetry and transitivity together give you the loops everywhere. Okay? You cannot have symmetry and transitivity and not have loops. Make sense? Okay, cool. Yeah, closure. Any questions so far? I think we are going to define something new now. This thing is transitive. Oh. So it's not transitive. It's not transitive. It's not transitive. Yeah. So I think it's a bad example. It should. That's why I said कि यहाँ पे नहीं होना चाहिए था. Yeah. You need A, C, and CA to make this thing transitive. Yeah.